Welcome to Mars Saga, your gateway to the Red Planet. Subscribe now and join the journey.
Mars Saga continues by exploring one of the most important chapters in the history of Mars, the era when water shaped the planet. Long before Mars became cold and dry, it was a world where water flowed across the surface, carved valleys, filled lakes, and possibly supported the conditions needed for life. Evidence collected from orbiters, landers, and rovers shows that water once played a major role on Mars. Ancient river channels, dried lake beds, deltas, and mineral deposits all point to a time when liquid water was stable on the surface for long periods. Early Mars had a thicker atmosphere and a warmer climate. Volcanic activity released gases that trapped heat, allowing temperatures to remain above freezing. Under these conditions, rainfall, snowfall, and surface runoff were possible. One of the strongest signs of ancient water is the presence of valley networks. These networks resemble river systems on Earth. They branch naturally, follow slopes, and connect to lower basins. Such formations are difficult to explain without flowing water. Many of these valleys formed more than 3.5 billion years ago. Their age suggests that Mars experienced a long-lasting wet period rather than brief, isolated events. Water likely flowed repeatedly over millions of years. Large outflow channels provide another clue. These channels are wider and deeper than river valleys and were likely carved by massive floods. These floods may have occurred when underground water reservoirs suddenly burst through the surface. Some floods were powerful enough to reshape entire regions in a short time. They transported huge amounts of sediment and left behind streamlined islands and scoured terrain. Ancient lake beds have also been identified across Mars. These basins once held standing water for extended periods. In some cases, deltas formed where rivers entered lakes, depositing layers of sediment over time. Deltas are especially important because they require calm, stable water. Their presence suggests that lakes did not evaporate immediately, but remained for long durations. Minerals formed in water provide chemical evidence of Mars's past wet past. Clay minerals, sulfates, and carbonates have been found in many locations. These minerals only form in the presence of water. Clay minerals indicate neutral or mildly alkaline water, which is considered favorable for life. Sulfates suggest acidic water that may have formed later as the climate changed. Carbonates show that Mars once had a thicker atmosphere rich in carbon dioxide. Over time, this carbon dioxide reacted with water and rocks, becoming locked into the crust. Water also interacted with volcanic activity. Heat from lava flows melted ice and released steam, contributing to localized rainfall and hydrothermal systems. Hydrothermal environments are of special interest because on Earth they support microbial life even in extreme conditions. Similar environments on Mars may have existed beneath the surface. Polar regions hold vast amounts of water ice. These ice caps contain layered deposits that record climate changes over millions of years. Seasonal freezing and thawing shaped the polar landscape. Glacial features are found far from the poles. These include ridges, lobes, and flow patterns that suggest ice once moved across the surface. Mars likely experienced ice ages driven by changes in its axial tilt. As Mars cooled, surface water became less stable. Rivers dried up, lakes froze or evaporated, and ice retreated underground. The atmosphere continued to thin, allowing water to escape into space. Today, most of Mars's water exists as ice beneath the surface or at the poles. Some regions show signs of seasonal briny flows, but liquid water cannot remain stable for long. Despite the harsh conditions, traces of water activity are preserved. These ancient records are frozen in time, allowing scientists to reconstruct Mars's climate history. Water shaped the surface more than any other force except impacts. It smoothed terrain, carved channels, and transported materials across long distances. The transition from a wet Mars to a dry Mars was gradual. As the magnetic field weakened, solar wind stripped away the atmosphere. Without protection, the planet lost heat and moisture. This transition changed Mars from a potentially habitable world into the cold desert seen today. However, subsurface water may have survived much longer, protected from radiation and temperature extremes. Underground aquifers could still exist in deep layers. Radar data suggests the presence of buried ice and possibly salty liquid water beneath the surface. If life ever developed on Mars, it may have retreated underground as surface conditions worsened. These hidden environments remain a key target for exploration. Mars's water history explains the difference between the northern and southern hemispheres. The northern lowlands may have once hosted a vast ocean, while the southern highlands drained water into these basins. Shoreline-like features have been identified along the northern plains. Although debated, these features align with the idea of an ancient ocean. If an ocean existed, it would have covered a large portion of the planet and played a major role in climate regulation. Sediments from this ocean would contain valuable records of Mars's past environment. These deposits are now buried beneath layers of dust and lava. Water also influenced erosion rates. Softer materials were worn away, while harder rocks remained elevated. This process shaped mesas, buttes, and layered terrains. Mars's water story is written across the planet. From dried riverbeds to mineral veins, every feature adds to the understanding of a once active hydrological system. Studying Mars helps scientists understand how planets lose water and habitability. This knowledge is important for studying exoplanets and Earth's long-term future. Mars Saga documents this transformation from a water-rich world to a frozen desert. The loss of water marks one of the greatest changes in planetary history. Mars reminds us that habitability is fragile and depends on internal heat, atmospheric protection, and long-term stability. The ancient water world of Mars may be gone, but its evidence remains, waiting to be studied. Thanks for watching. You were watching Mars Saga.